Hi dear students, in the previous lecture we completed in exercise 9a till up to the 5th question. Now today I am going to start from the 6th question here. Let's see what is the 6th question is. In triangle ABC, angle B is equals to angle C the given. Let's draw the triangle ABC now. What the given is, angle B is equals to angle C, and again you need to prove that the perpendiculars from the midpoint of BC to AB and AC are equal. There you need to prove. See here, the perpendicular from the midpoint of BC. First mark the midpoint of BC. Let the midpoint of BC be P. Now whatever the line, if you drawn from this midpoint to the AB and the AC, that two perpendicular lines. The two perpendicular lines are equal. You need to prove in the first question. Let draw that. That is, let draw now. PE is perpendicular to EB. And again, PF is perpendicular to AC. Now you need to prove that PE is equals to PF in the first question. Now write out whatever the given data is. P is midpoint of BC. Now from this you can tell that BP is equals to PC. And again given that these two lines are perpendicular to the AB and the AC, means here whatever the angle formed is equals to 90 degree. Now what you need to prove is P is equals to PF. Now let's take the two triangles and prove that these two triangles are congruent. If you prove these two triangles are congruent, means whatever the congruent part of these two triangles are, P and the PF, these two sides are also become equal. Now let's take these two triangles to prove. In triangle BEP and triangle CFP. Now whatever the corresponding angles and sides are equal, BP is equals to PC because it is given, and again angle B is equals to angle C, also the given. Again here whatever the angle formed are equals to 90 degree because PE and PF are perpendicular to AB and the AC. That is, angle BEP is equals to angle CFP equals to 90 degree. You can write this is also in the given data only. According to the which congruency condition you can tell that the two triangles are congruent, means two angles and one side. Two angles and one side means you can tell that AAS congruency condition, triangle BEP is congruent to triangle CFP. Now PE will become equals to PF, the remaining part of the congruent triangle according to the CPCT. Whatever the line drawn from the midpoint of BC, that is perpendicular to AB and AC, that lines are now become equal by proving that these two triangles are congruent. See, this is the first question we proved. Now let's move for the second question. What they asked to prove. See here, second question, the perpendicular from B and C to the opposite sides are equal. You need to prove. Again draw the triangle ABC. In the main given data, the given that angle B is equals to angle C, and again whatever the sides opposite to B and C, see for the B the opposite side is AC, and again for the C the opposite side is AB. Now the perpendiculars from B and C to the opposite sides. Perpendiculars means here This line is perpendicular to AB. From B, whatever the line you drawn, this is perpendicular to AC. You need to prove these two lines are, the length of these two lines are now equal. Let it be G and the H. These two points will be the G and the H. You need to prove that BG is equals to CH. Now to prove that BG is equals to CH, you need to take the two triangles. Whatever the two triangles you need to take means, let's take this triangle. Because in this triangle you will get the CH side. And again take the one more triangle as BGC. In this triangle you will get the BG side. If you prove these two triangles are congruent means, according to the CPCT, this length will become equal. Now in triangle BGC and triangle CHB, observe here, BC is the common side for both these two triangles. BC is equals to BC because common side. And again the given that in these two triangles angle C and angle B are equal, that is angle C is equals to angle B, given in the main data. And again we drawn from the C perpendicular to the AB and from B perpendicular to the AC, means these two angles will become now equals to 90 degree. That is angle BGC is equals to angle CHB equals to 90 degree. It is also given. Now according to the AAS congruency condition, can tell that triangle BGC is congruent to triangle CHB. From this can tell that the length of the BG and CH are equal by CPCT. See, this is the end of the question 6. Next move on for the next question, that is 7th one. See, what is the 7th question they given here? The perpendicular bisector of the side of a triangle ABC meet at I. You need to prove that IA is equals to IB is equals to IC. See, first draw the triangle ABC. Draw the triangle ABC. See, in the 7th question, the perpendicular bisectors of the sides of a triangle ABC meet at I. They given the perpendicular bisectors of the sides of a triangle ABC. See, the perpendicular bisectors of the sides of a ABC means here for the BC side, what is the opposite vertex is E. Draw one perpendicular bisector for BC side, means here this point will become the midpoint of BC and again it will make the 90 degree angle also. Let it be E. AE is the perpendicular bisector for the BC, and again for AC, what is the opposite vertex is B. From B draw the perpendicular bisector. Let that point be F. Now F will become the midpoint of AC and also this BF will make the 90 degree angle on AC. Now for AB, what is the opposite vertex is C. From vertex C, draw the perpendicular bisector on AB. Now let it be G. G is the midpoint of AB and again this, it will make the angle 90 degree. All these lines are meet at one point. We are going to call that point as the I. Now you need to prove that IA length is equals to the IB and again IB is equals to the IC. All these three length will become equal. You need to prove. What you need to prove? To prove IA is equals to IB, it is equals to IC. Now, proof. See here, for the proof, here, to prove first, IA is equals to IB. IA and IB are in the two triangles IGA and IGB. In these two triangles, you will get the IA and the IB side. Let's take these two triangles first and prove that these two triangles are congruent. In triangle IAG and triangle IBG. Now, whatever the corresponding sides and angles are equal, let it be mentioned here first. IG is equals to IG. First, you are going to write that one. IG is equals to what? IG. Because it is the common side. Next, AG is equals to GB. In the given question only they mentioned that the line drawn from this, the perpendicular bisectors of all the three sides are meet at one point is I, means whatever the perpendicular bisectors drawn from that opposite vertex, the line drawn from the opposite vertex are perpendicular bisectors, means here the G divides the AB into two equal parts, that is AG is equals to GB, because CG is bisects AB. Next, and again perpendicular bisector means here it is making the angle 90 degree, that is angle AGI equals to angle BGI equals to 90 degree, because CG is not only it will bisect, it is the CG is perpendicular bisector. So from here these two sides and included angle, these two sides and included angle, according to the SAS congruency condition, you can tell that triangle IAG is congruent to triangle IBG. Now from CPCT, you can tell that IA is equals to IB. Remaining part of a congruent triangles are also equal. Now IA is equals to IB, let it be call it as 1. Now move on for the next two triangles. Here see, observe here IA and the IC. If you take and again take these two triangles and prove IA is equals to IC. Consider these two triangles now. In triangle IAF and triangle ICF, IF is equals to IF, is the common side. And again BF is perpendicular bisector of AC, so from that you can tell that AF is equals to FC, because BF bisects AC. Next, angle AFI is equals to angle ACFI is equals to 90 degree. This is also in the given data from SAS congruency condition. SAS congruency condition can tell that triangle IAF is congruent to triangle ICF. Now the congruent part is I need IA is equals to IC. IA is equals to IC. From the CPCT, the congruent part of a congruent triangle is equal. Now see here IA will become equals to IC. Now observe the 1 and 2. IB is equals to IA and IC is also equals to IA, means what about from all the three will become equal now. IA is equals to IB is equals to IC. So from 1 and 2 can tell that IA is equals to IB is equals to IC. Yes, this we need to prove here. This is the end of the question 7. Next, move on for the question 8. See what is the question 8 is. A line segment AB is bisected at point P. Yes, let's draw the question now. Line segment AB is bisected at point P, the given. Bisected means this P will become the midpoint of AB. Now, and through point P, another line segment PQ. Draw the one more line segment through the point P, that is, let it be PQ. This line will become now perpendicular to AB. This line will become perpendicular to AB. Now you need to show that QA is equals to QB. Now to prove that QA is equals to QB, let's join this QA and QB. Now you can easily prove that these two sides are equal by proving these two triangles are congruent. First you need to write that join QA and QB. Now to prove that these two sides are equal, let's consider the two triangles in triangle QPA and triangle QPB. See, whatever the corresponding sides and angles are equal, mention here. That is, AP is equals to PB. Why that two sides are equal? Because in the given only, the given that P is the midpoint of AB or P bisects the AB. Therefore, QP is equals to QP is the common side for both these two triangles. QP is equals to QP, it is common side. And whatever these two corresponding sides are equal, this included angle is also equals to 90 degree, because here the given that QP is perpendicular to AB, that is angle QPA is equals to angle QPB is equals to 90 degree. It is given because QP perpendicular to AB. Now according to the SAS congruency condition, can tell that triangle QPA is congruent to triangle QPB. From this, you can tell that QA is equals to QB. Congruent part of a congruent triangle is also equal from CP, CT. As we proved in the question 8th. Let's move for the question 9th. See, in the 9th question, if AP bisects angle BAC and M is any point on AP, prove that the perpendicular drawn from M to AB and AC are equal, the given. See, let's draw the given, from the given data, draw the figure. AP bisects angle BAC. Let's draw first the BAC angle. See, like this. BAC. Okay. Now from A, let's draw the one more line, that is at point, and M is, okay, AP bisects angle BAC means from A, draw the one more line, that is AP. This line AP will now bisects the angle BAC. That is, these two angles will become equal now. That is angle BAP is equals to BAC. Now again consider that M is any point on the AP. Let's consider M is any point on the AP. Now draw the perpendicular line from M point to on AB and the AC. Draw the perpendicular line now. That is, draw M from M perpendicular to AB and perpendicular to AC. Let it be considered as E and the F. ME and MF is the perpendicular lines drawn from the point M. Now you need to prove that the the length of the ME and MF is equal. First, what you done here? You drawn the triangle BAC. From the point A, you drawn one more line, that is P. This PA line will bisecting the angle BAC. That is BAP is equals to PAC. Now, whatever the bisector is there, now PA will become the bisector of angle ABC. Now, whatever the bisector is there on that line, consider at anywhere point as M. Now from that point draw two perpendicular lines on the AB and the AC respectively. Now the length of that perpendicular lines you need to prove as the equal. This is the main question they given in the 9th one. Now see, you need to prove that ME and MF is equal. Both ME and MF is there in the triangle MAE and MAF. First you need to prove that these two triangles are now congruent. Consider now in triangle AME and triangle AMF. Observe here, AM is equals to AM. That side is common side for both the triangles. Next, and they given that ME is perpendicular to AB and MF is perpendicular to AC, means these two angles will become equals to 90 degree. That is angle AEM equals to angle AFM equals to 90 degree. It is given. Again, PA is the bisector of angle ABC, means that is angle BAP is equals to angle CAP. It bisects this BAC into two equal parts, CAP. It is also given. Now two sides and one angle is equal, means according to the AAS congruency condition, can tell the triangle AME is congruent to triangle AMF. Now the congruent part of a congruent triangles are, that is ME is equals to MF by CP/CT, which is drawn the perpendicular from point M is these two sides now will become equal. Hence it is proved. This is the end of the question 9. Now let's move for the last question of the exercise 9A, that is 10th one. See now, see the 10th question, the given the figure here. What the given in the figure is, the given that ABCD is a parallelogram, and again ABL is a line segment, and the given that E is the midpoint of midpoint of BC, and they join the DE till it meets the line ABL. Now they asked to prove, first question, triangle DCE is congruent to triangle LBE. First proof they asked. Now consider here the two triangles. Where we are going to get this one, DCE and LBE. These two triangles you need to prove. Let consider the two triangles DCE and triangle LBE. Observe here, what are the corresponding sides are equal now? That is, and side CE is equals to EB. CE is equals to EB. Why? Because the given B is the midpoint of BC. Next, observe this angle. These two angles are vertically opposite angle. That is angle DEC is equals to angle BEL. That is because of vertically opposite angles. Next, see one more third element you need required to prove these two triangles are equal. Now one side is equal, but remaining the other sides are equal or not, we don't know. But for that, you can take one more angle as like this. See, and this angle and this angle you can take. See, these two angles are now interior alternate angles. How these two angles will become the interior alternate angle means here. ABCD is a parallelogram. ABCD is a parallelogram means here DC is parallel to AB. And again, see here the AL line is the extension of the AB line. AB line means, now what it means? DC is parallel to AL. Now DC is parallel to AL means, see like this, DC is parallel to AL, it will becomes. Now what about this DL? DL will become the transversal now. Transversal, now see here, which angle is forming at the corner of the Z? That is interior alternate angles. These two are the interior alternate angles. These two interior alternate angles are now become equal. Now that is angle CDE is equals to angle ELB. Why? Because DC is parallel to AL and DL is transversal interior alternate angle. Now see, two angles and one side is equal means AAS congruency condition. You can tell that triangle TCE is congruent to triangle LBE. Okay, this is the first proof we done. Next, move on for the second proof. What they asked to prove second means AB is equals to BL they asked. Second is AB is equals to BL. Now observe here. So after proving this as the congruent triangles, now the DC will become equals to BL here. DC is equals to BL because of CPCT, congruent part of a congruent triangle. Now let's consider here to prove this AB is equals to BL. First let write down this AB is equals to DC. Why? Because AB and the DC are opposite side of a parallelogram. Side of a parallelogram. Next, from 1 you can write that DC is equals to BL. From 1. Observe these two now. AB is also equals to DC and BL is also equals to DC. Equals are equals to the same thing. The two are equals to the same thing means these two are also equal now. That is, can mention here 2 and this one as 3. From 2 and 3 you can tell that AB is equals to BL. This is the second proof. Next, move on for the third proof. That is, you need to prove that AL is equals to the 2 times of DC. AL is equals to the 2 times of DC. To prove that AL is equals to 2 times of DC, first write down that, take this AL only, LHS part. Whatever they given in the LHS part, let's take down this one. And see, observe in the figure, the length AL is the sum of the two sides AB and the BL. Yes, sum of the two line segments AB and the BL. AB plus BL you can write it as AL. AL as write it as AB plus BL. Now observe here. Now I am going to write this AB as DC. In the place of AB I will write DC. From 4 in the place of from 1 in the place of BL I will write it as DC. See, from 2 and from 1 I wrote in the place of AB and the BL as DC. Now AL will become equals to DC plus DC what? 2 times the DC. This is the end of the question 10. I hope you people understood this exercise 9A, and in the another video you can move for the exercise 9B.